Hello, good evening. My name is Onanyang Isaac, and I'm going to be taking you through week 1, which is Mlops, introduction to Mlops for facial emotion detection. And the content is Mlops itself, which is machine learning operations, which is a combination of the DevOps style methods and machine learning based practices focused on deployment and operation of machine learning models. The next term we have is DevOps, which is development operations, which is a culture of collaboration of developer operations to continuously improve deployment. The next is CI/CD, which is continuous integration and continuous delivery. Continuous integration involves regular automated testing and validation of the software which is being built. Continuous delivery majorly focuses on automatically releasing updates. Next term is maturity model, which is a concept in MLOps defining ascending levels, typically 4 to 5 of the MLOps sophistication and effectiveness, from unreliable to scalable. The next term is data ops, which is data operations, specifically focuses on the use of DevOps concepts and automation principles so as to manage the workloads like aggregation, transformation, storage, and analysis. Next is we are going to define MLOps and its relevance in facial emotion detection. MLOps, as earlier mentioned, refers to the practices, tools, and workflows aimed at operationalizing and scaling machine learning models effectively, and its relevance to the project, which is facial emotion detection. It helps us in determining the accuracy of the model, and it helps us in interpreting the model, and it also ensures the reliability of the model. And then how the MLOps trends and techniques influence facial emotion detection is: 1. We have model interpretability technique. In this, it helps us to understand the factors influencing the model's predictions, and it can be the trends also influence in continuous integration and continuous deployment. In this aspect, it ensures that the model stays relevant and effective, detecting emerging facial emotion expressions. The next aspect is model monitoring and maintenance. In this, it helps us to ensure continued reliability of the facial emotion detection models by identifying issues and corrective actions such as retraining models or updating features. And we have the next as application of DevOps and data ops. DevOps can be applied in model deployment. That is, model deployment is model development. And development, as we know, is a procedure in which the model is created. And DevOps can be also applied in model deployment and monitoring. In here, as the model is being deployed to the environment, DevOps, which is development operations, can be used to help us to deploy this model and also monitor it while it's in the environment carrying out its operations. Next is helps us in feedback loop and iteration. That is, in simple terms, helps us in tracing its operations and giving us the feedback on how it has performed the activity it was assigned to do. Then data ops are applied in data collection and pre-processing. Data collection is gathering the information which is going to be fed on the model, and pre-processing involves various activities, which is one of them is data cleaning. And data ops is also applied in feedback loop and iteration, as mentioned earlier. Then we have the differences between heavy and light MLOps in the project. heavy MLOps involves infrastructure setup, automation and orchestration, then model training plus the rest. And then light MLOps involves simple infrastructure, basic automation, limited experimentation, plus the others. And then we have integration of MLOps hierarchy of needs and maturity models. And here we are given the MLOps hierarchy of the needs as data model, process, monitoring, and governance. And the MLOps maturity models, we have initial stage, managed stage, defined stage, quantitatively managed stage, and optimizing stage. Next is have strategies to handle data poisoning, data drift, and operationalizing microservices. Data poisoning means it can be covered through data quality assurance, robust model training, and regular monitoring. Data poisoning, here they are trying to tell us data poisoning arises due to what? The collecting data which is inaccurate, improper to be used what? To be used or to be applied onto the model. And data drift, here you can handle it through monitoring and detection, revalidation and training, and feature engineering. And then operational microservices, we have containerization, service orchestration, API designed for interpretability, monitoring and logging, then deployment pipelines. Those are the ways of what? Covering the above problems. And then you have the role of continuous integration, continuous delivery, and feature stores. Continuous integration, it ensures that the changes in the machine learning model code base are regularly integrated and tested to ensure that the model stays in line in what it's supposed to do. In continuous delivery, it helps us to validate machine learning model as it's being deployed rapidly and reliability. In other words, help us to ensure that the model is reliable. And then the feature stores. They store pre-computed features derived from raw data sources, making them easily accessible for the model training and inference. And then the importance of the specific files in a Python project, we have the README, which provides essential information about the project. And then the requirements.txt, it lists all the dependencies required to run the project. And then we have data itself, which contains the data sets to be used to train the model. And then we have the source. Here it houses the source code of the project, including Python scripts. These are pieces of code. And then we have models. Here they store the trained machine learning models and their associated metadata. Metadata simply means data about data. Then we have documents. Here it contains the documentation of the project and explanation of the key concepts governing the project. Thank you.